Our last topic in network laws and theorems is the Norton's Theorem. So this theorem is an alternative to the Thevenin's Theorem. In fact, it is the dual of Thevenin's Theorem, whereas in Thevenin's Theorem reduces a two-terminal active network of linear resistances and generators to an equivalent constant voltage source and series resistance. Norton's theorem replaces the network by an equivalent constant current source and a parallel resistance. So here, it is also the same principle in DC circuits. So example, this is our circuit, and then we have to find the current ISC. So we remove the RL or the ZL of that circuit and then replaces it with a short circuit. So after replacing short circuit, you need to solve the ISC or the what we call IN or the Norton's current. This one. So after solving the ISC, now you will solve the RN or the Norton's resistance or the Norton's impedance. Same in Thevenin's theorem. ZTH and ZN is the same. So after solving the ZN and the ISC, this will be now your final circuit. Terminals A and B is the impedance which you removed from your original circuit. So our RN and the ZN will be in parallel. Now you are ready to solve the current flowing in terminals A and B by using the current divider theorem. So IL now will be equal to ISC multiplied by ZL divided by the total impedance, which is the RN in parallel or RN plus ZL. As applied to AC networks, this theorem can be stated as any two-terminal active linear network containing voltage sources and impedances, when viewed from its output terminals, is equivalent to a constant current source and a parallel impedance. The constant current is equal to the current which would flow in a short circuit placed across the terminals, and the parallel impedance is the impedance of the network when viewed from the open circuited terminals after voltage sources have been replaced by their internal impedances, and the current sources by infinite impedance. So we will take examples for Norton's theorem. Use Norton's theorem to find the current in the load connected across terminals A and B of the circuit shown in this figure. So we will find the current flowing in 10 minus J10. So let's say this will be our IL, and our ZL will be 10 minus J10. So first, we need to short circuit terminals A and B, then solve for IN or the Norton's current. So we will rewrite our circuit, short circuiting our ZL. So rewrite or redraw. This is now our ISC or IN. So this is 100 angle 0, negative J10, 10 and J10. From this circuit, how will we solve for ISC? So as you can see, the current flowing here without any resistances and inductance or simply impedance, it most likely will open this branch. So it will be simply negative J10, and our source. This will be our ISC. So, ma-open yung branch na to kasi mas malaki yung current na pupunta dito sa branch na to dito. So, ISC now will be equal to Ohm's law. ISC is equal to the source divided by negative J10. So, ISC is equal to 100 angle 0 divided by negative J10. That is equal to 10 angle 90 degrees amperes. After solving your ISC, next will be your RN or ZN. Second, solve for ZN. So, remove all the voltage sources. Ang matitira na lang ay yung mga impedances. We will redraw our circuit. Then, we short-circuited all the voltage sources. So, this is now our ZN and our impedances, negative J10 and 10 plus J10. So, as viewed, looking back into our circuit, our ZN will be negative J10 in parallel with 10 plus J10. So, negative J10 times 10 plus J10 divided by negative J10 plus 10 plus J10. Zn now will be 10 minus J10. So, after solving the two parameters, we will now redraw again our final circuit. Our final circuit in Norton's will be the impedances RL, impedance ZL, and impedance Zn will be in parallel. And also our short circuit current or our IN, this is IN or ISC, in parallel with the impedances. So, ISC in parallel with Zn in parallel with ZL. And we are aimed to solve for IL, the current flowing in impedance L. Using CDT, IL will be equal to the source current multiplied by ZL divided by ZL plus Zn. So, IL now will be 10 angle 90 multiplied by 10 minus J10 divided by 10 minus J10 plus 10 minus J10. Our IL, current flowing in impedance L, will be 5 angle 90 degrees amperes.